All right, you already took notes on this part of the section, so I'm just going to just really quickly go over it in case you have any questions before you complete the assignment. All right, so in the book, you should have found on one of the pages the general form of the equation of a line. Now, in my notes, when I have a box, it means there's a box in the textbook as well. And just please know that anything in a shaded box in a mathematics textbook is important information. That's why it's in a shaded box, to call your attention to it. All right, so you should have seen the general form of the equation of a line, ax plus by plus c equals 0. Now, sometimes this would be written as ax plus by equals c. Notice the capital letters here. The capital letters, I'm not sure if you've ever learned about this in another math class, but there's a reason why these are capital letters. And the reason is because these coefficients of both x and y and this constant here, they would all be integers, not fractions. Okay, so if you end up with a fraction, you've got to multiply through by, the least common denominator to get rid of those fractions. So keep that in mind. That's why this is capital, and this is capital, because that is indicating that these values here are all integers. If you think of the y equals mx plus b equation, the m and the b are lowercase, whereas this a, b, and c are uppercase. Okay, this question says to find the slope and the y-intercept of the line whose equation is this. Now remember, I had asked you to use the examples that were in the checkpoints. This was checkpoint number 7. Okay, so you go through the process. You had to find the slope and the y-intercept. Well, it makes sense to put it in slope-intercept form. So just solve this equation for y. Take the 3x over, take the 12 over, divide by 6. Each of these terms, divide them by 6, and then simplify it. You must always, always, always simplify it. Your slope, symbol for slope is m. M equals -1/2. And your b or your y-intercept is always an ordered pair. Folks, please, please, please write it as an ordered pair. I don't want to have to take points off on a test, but if you don't write it as an ordered pair, I do take points off. The y-intercept is a point on a graph with coordinates x, y. Okay, and the x value is always 0. How would you graph that equation? Well, simple. You're going to plot the y-intercept and use the slope to find other points. So hopefully you were able to fill that in. So you'll have an upcoming really short quiz on point slope, slope intercept, and standard or general form of the equation of a line. And on that quiz, you're going to find this same exact thing. I just simply copied and pasted it and probably moved these around so they weren't in the same order. And on your Schoology quiz, you're just going to have to match this up. So, you're not going to be able to draw lines. Okay, but you certainly could say number 1 matches with letter D. Y equals mx plus b. This is slope, this is intercept, that's the slope-intercept form. Y equals b. That's a horizontal line. And we're saying that y equals b because b is the symbol for slope-intercept, and a y equals equation would pass through the y-axis. And you would have a y-intercept. All right, so there's your horizontal line. This is your general form. This is your vertical line. Okay, x equals a. Well, we can't use the b, right? X equals b because, we have y equals b. X equals a. That's your vertical line. Typically, your vertical line is never going to have a y-intercept unless the vertical line is the line x equals 0, and then it would have infinitely many y-intercepts because it would be the line drawn right on top of the y-axis. So keep that in mind. This down here, this is point slope because this x1, y1 are coordinates from a point. M is the symbol for slope, hence point slope. Okay, it just kind of makes sense. It's pretty logical. Why this is called point slope and why this is called slope intercept. All right, where do students usually get incorrect? They mix the y and the x equations up. I mean, if it's an x equals, you're going through the x-axis. That's going to mean a line going this way. That's your vertical line. All right. On side 2 of the notes, it took you through something about parallel lines. there are lines that lie in the same plane that have the same slope. And so I wanted you to just draw something there, you know, a pair of parallel lines, and talk about the slope. You know, if I look at the slope of this line, you know, I'm rising 2, running 1, rising 2, running 1. So the slope of the first line is 2. Now, notice my subscript here. That's the symbol for parallel from geometry. Then the slope of the parallel line is also 2. And notice that these two lines will never intersect. They have the same slope. Their rate of change is the same at every step of the way. They're never going to intersect. The y-intercept is different with parallel lines. They can't have the same y-intercept. If they do, then it's the same line. Then we call them coinciding lines. All right, so parallel lines have the same slope. And we'll take a quick look here at the bottom of the page. Perpendicular lines have slopes that are opposite reciprocals. Folks, lines that are perpendicular, they meet at a right angle. Okay, they meet at a 90-degree angle, a right angle. The slopes are opposite reciprocals. When we say opposite, we mean the sign is opposite. Okay, this is positive, this one's a negative. I mean, just look at these two lines that are perpendicular to one another, creating right angles here. You know, if I look at this from left to right, this line is rising. That's a positive slope. And this one's falling. That's a negative slope. Perpendicular lines always have slopes that are opposite reciprocals. Now, of course, you know, I could graph the line x equals 0 and y equals 0. They would be perpendicular, right? The axes are perpendicular to one another. The slope of the vertical line is undefined. The slope of the horizontal line is 0. And you get undefined when you flip that fraction because you're dividing by 0. So keep that in mind. When you multiply the product of the two slopes of perpendicular lines, it's always going to equal -1. Always, always, always. You should have read about that in your textbook as well. All right, so what kinds of problems will you have? Well, you know, it's saying here, write the equation of the line that passes through the point, -2, 5. That's parallel to this line. So the only information you need from this equation is the slope. And I know that I'm going to pick up and use the same slope because the lines are parallel. Same slope, parallel. So the slope of the parallel line, look at my subscript, is 3. It's the same. And it has to go through this point, -2, 5. There it is. I've got my 3 items. I'm going to use the point slope model. And I'm just going to substitute the x and the y. Make sure you put them in the right place, okay? This is the place for y. Sometimes students don't like to write the model. And then they put the x here and the y here. And I'm like, no, you can't do that. You got to put it in the right spot. You got to put the y in for y and the x in for x. You can't mix them up. It's a different ordered pair if you mix them up. All right, so this is my equation in point slope form. I'm going to abbreviate PS for point slope. Remember, when you're putting in point slope form, you should easily be able to identify the point. Okay, so I've got 5, -2. And easily identify the slope. Now, folks, if the slope is 1, you should write a 1 there. If one of the coordinates is 0, you need to keep the 0 because proper point slope form has an entry for all of these items, the m and the x1, y1. All right, so there's my point slope form. And then all I have to do is distribute here and then take the 5 over to get my slope-intercept form. I think we saw this before in an earlier video. The new thing here really is, what slope do you use? Well, if I want a line parallel to this line, it's got to be the same slope. And this kind of problem on page 3 of the notes, I told you that you only had to do up to page 3 on the notes. The top of the page, right? This word problem or the application problem, we're saving for another day, another lesson, probably tomorrow. All right, find the slope of any line that's perpendicular to the slope whose equation is this. So you want to circle your key words like perpendicular. And you want to read this and understand what it's asking you to do. It's just asking me to find the slope of any line that's perpendicular. It's not asking me to write an equation. Now, if it's asking me to write an equation, I have more work to do, like I had in this problem. Okay, but that's not what it's asking me. It's asking me to give the slope that would be perpendicular to this line. All right, so this is in that general form. I have to convert it to y equals so I can identify the slope. So we just go through that process. We move the x, we move the 12, we divide by 3. And here's my slope-intercept equation. So then what I'm going to do is identify the slope of this equation, which happens to be negative 1/3. And if I want the slope of any line that's perpendicular to this line, any line, they're not giving me a definitive point. It's just any line. I'm just looking for slope. That's it. I'm going to change the sign from negative to positive. I'm going to flip the frac. Okay? Yeah, flip it. 1/3 becomes 3/1 or 3. So this is the answer to my question. That's the slope of any line that's perpendicular to this line. Again, if they gave you a point and said it has to pass through this point, then you have more work to do, like checkpoint number 8 in the parallel part. All right? So make sure that you can differentiate when lines are have the same slope versus when they have slopes that are opposite in sign and reciprocal in rise over run. If you have any questions, post on the discussion or ask in a Google Meet. Here's the assignment, page 189, 47 to 67 odd. We will continue and pick up with the line of best fit in the next lesson. Have a great day.